Hello everybody, my name is Ben, and welcome back to my channel. Today I am doing something a little different from what I normally do. Today I'm going to be making a science video. Something that probably interests me just as much as running is science. And I have come up with a design for a pretty cool project that I'm working on. It'll probably be a multi-part series, and I'm going to be showing you the design and just everything to do with the project that I've come up with so far, problems I've identified and such. So, yeah, stick around. Just let me grab my marker. Alright, so, the project I'm going to be doing is an optical quantum computer. Think of lasers, lenses, things like that. So for the optical quantum computer, there are a bunch of different components and they work together in different ways. I'm going to be going through each one. So here we have the laser. The laser I'm going to be using is a red laser at 650 nm. It's a laser diode, and it's pretty straightforward. It is what we're going to be using. We're going to be using the polarization of the light to function as our qubit in this scenario. So then we have what I call sort of the error correction stage. We're going to have two sheets. This is going to be the ND filter. Alright? This is just going to be responsible for filtering out unnecessary wavelengths and things like that. Or not unnecessary wavelengths, but just excess light and such. Here, we are going to have the polarization film. So this is pretty important because we're using the polarization of the laser beam in order to detect a superposition. The reason why this is so important is because we want to know its initial polarization state, whether it's a vertical or horizontal polarization. So then we get to the main parts of the system. So here we have our wave plate. So the wave plate is probably the most important piece in the system because it allows us to create a superposition of the polarization of the light. It allows us to say, hey, we don't want it to be vertical, we don't want it to be horizontal, we want it to be somewhere in between. Then here we have the polarized beam splitter. This is also very important. So what happens is the wave plate puts it at maybe a 45-degree angle. And the polarized beam splitter will say, hey, you either decide you want to be a vertical wavelength and you go through, or you want to be a horizontal wavelength and you get bounced off. And the way we're going to be reading and getting these readings are photodiodes. Very important. So the idea is that I will draw the laser. So this is error correction. This is our actual quantum circuit as the wave plate. And then we have the, not necessarily quantum circuit, but are creating a superposition in general. Then we have the polarized beam splitter, which forces the wavelength to either collapse into a vertical or horizontal orientation. And for a little bit more info to what we'll be doing. Alright, so this is our ground, and the photodiodes are going to be connected to a microcontroller of some sort, as well as the laser, just for ease of control. So for context, this, I will say, this should easily be able to create 50% chance probability, 75% chance probabilities, and really show it with the readings. The biggest problem with this system is that the photodiodes, we're going to have to carefully calibrate it, not necessarily the photodiodes, but the system, in order to say, hey, this photodiode is preferred by the wavelength over this photodiode, which should be easy to code, but the problem is that it's quite possible we'll get a 50-50 rating for each one if we have maybe, say, a 45-degree or 50-50 wave plate. So these two will probably give identical readings a lot of the time. So we're going to have to obviously do some bug fixing to fix that and such. Maybe focus on timing, things like that. Right now, the biggest hurdle for constructing this on my own is the wave plate. Wave plates are very expensive. All the other parts, lasers, ND filters, polarizing films, photodiodes, polarized beam splitters, things like the ND filter, photodiodes, polarized beam splitter are a little hard to get your hands on, but you can find them for very realistic prices. The wave plate is quite expensive. So I'm currently looking for deals. I don't know if you know anybody who sells 45 wave plates at a good price. Hit me up. So this is the design. I'm going to be working on it. This is going to be a multi-part series. So once again, thank you so much for watching the video. There will be more shoe content. I just wanted to do a little something else. And please remember to like, subscribe, comment, do all those things, and come back again for another video. Have a good day.